Hi guys, I'm going to correct the work on the Haber process. Make sure you check your answers if I didn't give you feedback. So temperature for the Haber process making of ammonia 450 degrees Celsius, pressure is 200 atm, and catalyst, it's iron catalyst, and it should be finely divided, and it's finely divided because that is going to provide large surface area, so that's going to make it more effective. So normally high pressure and low temperature preferred. Why high pressure is used? So if we look at the equation, so here you have one gas and three gas. So in the reactants you have a total of four gases, let's say 4 particles of gases, and then on the product side you have 2 particles of gases. Okay. So on reactant side, so high pressure here, so high pressure, and this is low pressure. So if we are using high pressure, the equilibrium will want to oppose that high pressure, so the equilibrium will now want to lower the pressure. So we are using high pressure, so the equilibrium will want to shift towards low pressure. So to shift towards low pressure means that the forward reaction will be favored, so it's going to shift towards the product side. Okay, so explaining. So when you increase pressure, it's going to cause the equilibrium to shift on the right hand side. So right hand side is the side of the product, so where there's less volume of gas, hence going to increase the yield. So I've explained the effects. So I've given the effect, so it increases yield, and I've given the explanation behind that effect. Okay. Explain the effect of using low temperature. Now if we look at this reaction, you will see that this one, so delta H is negative, which means that it is exothermic. So let's look at the reaction here. So reactant into product, so this is exothermic, and during exothermic you'll have temperature that goes up. Now from product to reactants, now it's going to be the reverse. It's going to be endothermic, and during endothermic reaction temperature is going to go down. So what are we doing? We are using low temperature. So what will the equilibrium want to do? It will want to oppose it. So it will want to have higher temperature. So which one gives higher temperature? So it's the forward reaction. So what will be favored now? So the forward reaction will be favored because this is what causes an increase in temperature. We are lowering the temperature, the equilibrium will want to increase the temperature by favoring the forward reaction. So explain the effects. So a lower temperature is going to cause the equilibrium to shift to the right hand side. So it causes the equilibrium to shift to the right hand side. So this is the right hand side, shift to the right hand side, as the forward reaction is exothermic. So forward reaction is exo, so backward will be endo. So because forward reaction is exothermic, hence yield is going to increase. So we decrease temperature, equilibrium will want to increase it. And how does it increase it? By favoring the forward reaction. And why is this exo? Because it's given over here, it says it's negative, means it's exo. So this one indicates what's the forward reaction. So if forward reaction is negative, exo, then backward reaction will be positive, endo. Explain why lower temperature is not used. So low temperature will increase yield, but it's going to cause the rate of reaction to be really low. because it's an industrial process, so you want the product to be produced like fairly quickly and in a large amounts. So yield is the amount that you get, rate is how fast you get it. So if you use a temperature that is too low, we're going to end up with a rate that is really slow. Okay, so the answer for this, so a lower temperature is going to cause the reaction to slow down. So it slows down, and because at low temperature particles have low kinetic energy, less successful collisions, hence rate is slow. So this is explaining. So I'm saying what will happen, slows down, and I'm explaining why it will happen, because particles have less kinetic energy, there's less successful collisions. Now explain the effect of the catalyst on the amount of ammonia. So what is a catalyst actually? A catalyst is a substance that speeds up a reaction without itself being used up. So it just speeds up the reaction. It does not increase the amount of product. So it's just going to increase the speed of reaction. So it increases the rate, but it does not affect the yield. For you to be able to change the yield, you can only change temperature, pressure, or you can change concentration. But for you to be able to change the rate of a reaction, then you'll have to add a catalyst, or alternatively you can also change temperature, because high temperature gives high rate. Okay, but to affect yield, there's only temperature and pressure, and this is only going to be because of the equilibrium. Shifts in equilibrium will affect the yield, but catalyst will affect the rate. So the catalyst is actually going to increase rate, but it has no effect on the amount of ammonia formed. Now for this question we can elaborate a little bit more, but we haven't really covered the theory behind catalysts yet, so more details is going to come after. For now, that's enough. So for the second question now, so for this question there is a little information that is missing over here. Sorry about this. So you just had to be given that delta H is going to be, it should be negative. Okay, so this part should have been given. I forgot to give you, or didn't include this. Okay, so at first rate of forward reaction decreases with time. Suggest a reason for this. So as the reaction starts, so you have the reactants over here. So reactants here, they are being used up at first. So as they're being used up, concentration of reactants will decrease. So the reaction will want to increase it. And how does it increase it? By favoring the backward reaction. So when it favors the backward reaction, then the rate of forward reaction decreases. Okay? So now why rate of backward reaction increases? These two questions are kind of the same, but they are asked in different ways. So backward reaction, why will it increase in time? So the reaction is exothermic. So when the mixture is heated, the equilibrium will shift so as to decrease the temperature, hence favor the reverse endothermic reaction. So a high temperature is going to cause the equilibrium to shift to the left so as to favor the endothermic reaction. This is for 1 mark, so I'm brief on this while giving the required details. So equilibrium will shift to the left. To the left means backward. Okay, so to the left means backward. And why? Because it has to favor the endothermic reaction. how do rates of forward reaction and backward reaction compare? After the equilibrium, they will both be the same. So rate of forward reaction is equal to rate of backward reaction. So they would be the same because it is after equilibrium. Now, what effect of increasing iodine on the... So if you increase iodine, so you have Hi plus 2Hi. Okay, so increasing iodine concentration, so you increase this, equilibrium will want to oppose it, so go against it. So then it will want to decrease iodine concentration. How does it decrease it? It will favor the forward reaction. Okay, so it will shift the equilibrium to the right hand side so as to decrease iodine concentration. So equilibrium will shift to the right, so over here it will shift to the right as to decrease the concentration of iodine. So we're increasing it, we want to decrease it. This causes an increase in yield of Hi. So this is going to go down now because we have shifted the equilibrium. So it's going to cause an increase in yield of Hi. Sorry, this is H2. Okay, fine. So that's for the explanation. 7.3 is completed. Make sure you are able to do all these different parts from the syllabus.